Hi everyone. Today I'm going to show you some of the functions and some of the things you can do in raster GIS using R. And I start out by installing the raster library. The raster package has got lots of functionality. We're not going to go over everything today, but we'll cover some of the key stuff. Now, just to give you a sense, I'm going to assume that you already know the idea behind raster GIS and the idea of raster data structures and so on, so I'm not going to review that. But if you want to visualize what it looks like in some sense, this is a way to think about what a raster layer can look like as it's structured in a GIS and used in a GIS. So it's a matrix with some number of rows and number of columns, and what we do is we turn that matrix into a raster layer in R, like this. So here I can, once I load the library, I can just show you what this looks like. It's just a data structure with 20 rows and 20 columns. It's a 20 by 20 raster layer with values. And then to turn it into an actual raster layer that will be understood and usable as this class of raster layer class, all you got to do is use this little raster function. So that turns this matrix into a raster layer. Now, in your case, you probably will be importing a raster layer. I'll show that process in another video. But here I'm just showing you how to turn a matrix into a raster layer manually like this. You can see the specific values inside the layer this way. So in this particular case, rast, and then using this little 1 here is going to give me the first. It's going to set, in this case, it's going to set the first cell in that raster layer, the first element in that layer, to a new value, the value of 1. And I'm just going to plot this out so you can see it. You can now see this here value, this green one, is the one I just set. So that's how you can directly access the actual cells in the raster layer. So it's very easy. I'm going to reset it now to 0. And we can plot it again and see that now we have just the data as it was, except that now I've set this value to 0. I'm going to create another raster layer here. Same way. In the first example, I set all the values to a number drawn from a random uniform distribution times -1, and now I'm doing the same thing, except I'm just removing the -1, the product of -1. So I'm creating this second raster layer. Now, let's say we want to crop the layer. I'm just going to show the dimensions of this layer. So this show function shows you the dimensions, that shows you the number of rows, the number of columns, the total number of cells, the resolution of those grid cells, which you can set, and the extent. The extent is 0, 1, 0, 1. This is the extent of the axes. So all the kind of key metadata related to that raster layer. And I can use this extent function to create an extent of any size. So I'm creating a new extent. It's just called extent. It's just a class of extent. You can't plot this, but it's this class can then be used to crop the extent of an actual raster layer. So if I want to take this raster layer here, the second raster layer that I created, I can crop it with this extent that I've created and then plot that. So this is one of the ways you can actually crop out data. If you're dealing with relatively simple dimensions, this is a way to crop it out. And then I can set the values to this layer all to -1. What I'm going to actually do here is create yet another matrix that I then turn into a raster layer using the same technique I just showed you earlier here, just turning this same newly created matrix into a raster layer. And I'm going to change the values in some of that layer. So in this case, I'm going to use this extent inside the square brackets of this newly created raster layer. And so what this is basically saying is that for any cell within this extent in this raster layer, I'm going to set the values to 0. And it looks like this. So this white area here, I've set all the values there to 0. So it's a nice and easy way to set values to set data to some values in a raster layer. So I set these values here to 0. And then what I can do is actually take the product of the first raster layer I made and this newly created raster layer in which I've got this little block of zeros. And I can go like this. So now I've got a new raster layer. And the values in this new raster layer are the product of the values in this raster layer and raster 3 and raster 1. So I've combined their values. And I can plot this raster layer. I'm multiplying the values of the cells in the layers. And as you can see, I've got zeros set here because they were the zeros in the raster layer 3. And everything else is just the product of the cell values. Same way. So this is basic map algebra, or raster algebra that we see. It's very simple to use. The last thing I wanted to show you is a little bit about smoothing these raster data. So there's lots of instances in which you might want to do something like this. So what I want to do here is create yet another matrix. And this one here, I'll just show you. I'm setting it. It's a 3 by 3 matrix with values set. So each cell has a value of 0.111. So I'm basically setting every cell or every element in this matrix to an equal value, which is 1 over 9. You could set it to anything. This is just an example here. Now what I want to do is use this window. This is something that you do in a GIS to smooth data, let's say. You might find some simple, this is a really simple smoothing function, not very sophisticated at all. It's just for demonstration purposes. But basically I want to smooth the values in this layer with this smoothing window. What this focal function is doing is it's going to each cell in the raster, and it's doing the following. It takes the cell, let's just take this little pink cell here, and it's saying, I want you to sum up all the values in all the cells within the window size being passed over it. In this case, the window is 9 by 9, so it looks at the window, then all 9 cells, and it's summing up the value of those cells. And then but it's multiplying them by the weight in this matrix, in this window. So in this particular case, it's taking the sum of the values, multiplying it by the weight in this one, summing that all up, and it's assigning that value to the raster, to the new element and an element in a new raster layer. And by doing this, it's basically smoothing. It's passing a window over all the data, and it's smoothing out the variability in the data. And you can see it. If we go here, we can see that all the data have been smoothed out because the information from neighboring cells is being used to change the values in the new layer. And in turn, smooth it out. And we can kind of see what the impact of this is, not just visually, but we can quantify it by using this Moran's function, which is basically a measure of spatial autocorrelation. It's saying the degree to which neighboring areas are similar in value. So I'm creating a new matrix here because when you're using Moran's, you need to specify a window that's going to be that's defining basically the neighbor structure. So in this case, we have a 3 by 3 window again, and this is how I've created this particular matrix. You can do anything you want. Your smoothing window or your spatial autocorrelation search window can be anything. You can create any sort of spatial weights matrix you want. But here, I've created that one. I run Moran's I here, and I see different values. The higher Moran's I, in this case the one that's closer to 1, is in a layer in which I've imputed a degree of spatial autocorrelation by passing this smoothing window over it. The first layer, I've not put any of this. It's just random data. I see very low level of spatial autocorrelation. So this is kind of what we'd expect to see having smoothed these data. Okay, so what we've seen is we've seen some basic input operations using this, some of the functions of this raster library, including how to turn a matrix into a raster and some basic raster algebra, as well as some of the idea of using a window, so creating a matrix and using that matrix as a window to do both smoothing but also calculate this measure of spatial autocorrelation. See you next time.